Hello guys, so I'm back again with another video on Krypton. So this time we'll be working on Krypton level 2. So last time we got the password for Krypton level 2, and now using that password we are going to get the password for level 3. So let's see what all do we have over here. So this time it says that it will be based mostly on rotation because they are saying rod 13 is over here. The another more important detail that they have provided here is the monoalphabetic cipher, which basically means you substitute one character by another character and that is fixed. Like they have given an example over here that A is always substituted by a character G, C by I, D by J, and so on. So that is why it is called monoalphabetic. Only one character gets replaced. And this is also called as Caesar cipher. Okay, and yeah, they have also provided one more detail that the password for level 3 is encrypted in a file named Krypton 3 and it is grouped in a group of 5 letters. Okay, the other thing that they have, this is the additional information, that there is a binary called encrypt and we can use that to decrypt the pass. Like, okay, we can basically test, like the function encrypt would be creating the password and that is the use of that file, but we won't be using that. I don't think so we are gonna need it. Okay, so we will begin with, okay, let me just start my terminal. Okay, and let's just try to SSH into, is it Krypton level 1, I guess? Yeah, don't know if I'm having the command over here or not. Yeah, so that is Krypton 2. The password for this level was, I suppose, root. I hope so it's correct. No, it's not. Maybe rotten. Oh wait, Caesar is easy. Not this one also. Maybe rotten. Yeah. So we got the shell for level 2. Now let's get to the directory Krypton. Oh, sorry. CD Krypton 2 plus LA. So I'm using here the switches L and A so that it lists all the files including the hidden ones. And yeah, here we have the file Krypton 3. So let's just cut it out. Krypton 3, and here is the encrypted password, so we need to decrypt it. And what all hints do we have over here are, this is basically using Caesar cipher and monoalphabetic cipher. Yep. Both of them are the same. So what we can do is we can write a Python script for this. So we'll start with the shebang etc bin environment Python. We'll be importing string, we will be importing collections and nothing else. So what my basic idea over here is, like, I'll be writing a function named rotation and I'll be passing two parameters. One would be the input and another would be the rotation value, like how much do we need to rotate, because you see basically over here Caesar cipher is nothing but it is just simple rotation by a particular number of characters. So that is what we'll be doing over here. So first we'll need all the characters in English, and over here we can see that the encrypted password is in all capital letters, so we'll just take the capital letters only, and we can do that by all alphabets equals collection.dq, and this would include string dot underscore, what is that, uppercase. Okay, so let's just try to maybe I'll just show you before what all is this, and then we'll begin with the print alphabets. Okay, so here you can see that all the alphabets from A to Z have been printed in a DQ. So now what is DQ? So let me just show you collections DQ Python. I had searched all of this earlier only. Yeah. So what does it say? So DQ is basically nothing but double-ended queue, and it is implemented using the collections module provided by the Python. And something interesting about DQ is it helps in quicker append and pop operation from both the ends of the container. So it means you can pop from here or here and do the same for insert as well. You can insert at the end and as well as at the beginning of the array, or whatever you call it, the queue. So that is what a DQ is, and you can implement it using the collections module in Python. Okay, so now the another thing that we'll be using is rotation. So for rotation, what we can do is we have alphabets, right? So alphabets dot rotate by value, say 3, and let's print alphabets once again. Print alphabets. Yeah. So here you can see that XYZ have come to the beginning of the string, and ABC has moved 3 values forward. We can also do this for negative values, and in that case what will happen is, see, ABC goes at the end of the queue. This is why we are using DQ over here, because it allows us to do such kind of operation, because if we were using queue, then this wouldn't have been possible to perform such operations. Okay, so now what we are gonna do is we will enable this function, and let's see what all can we do. Okay, so rather than this, I'll convert this into a string. Alphabet equals join alphabets, and let's see what. Okay, we don't need this other. Okay, and do that as well. Print alphabets. Let's see. So here you can see instead of printing it in the form of a queue, it has printed it in the form of a string. That is the benefit of using join function. It concatenates the entire queue and converts it into a string. Okay, so let's just enable this function, and let's just so now what? So now we know we are having two major things. We have implemented a DQ, we are rotating the characters. Okay, so now here we'll change the value by the value that we have passed to the function to rotate, and okay, so now we'll be returning what we desire, that is input dot translate string dot. I'll explain all of this, what all I'm writing over here. String dot ASCII uppercase along with upper. That's alphabets. Okay, cool. So let's just understand what the translate function does first of all. Python string translate. Okay, so let's see what we have over here. So this function basically returns a string where each character is mapped to its corresponding character in a translation table. And the another thing that is provided over here is the translation table is created by a static method makeTrans that we are using over here, string.makeTrans. Let's see what makeTrans is as well. Python makeTrans. Okay, so the makeTrans method returns a mapping table for translation of usable for translate method. This is a static method that creates one-to-one mapping. Okay, that is all that we need. So what is happening over here is like we are creating a one-to-one mapping between the uppercase characters and the alphabets. Now note that this alphabets currently contains the rotated values. It does not contain A, B, C, D in its proper sequence, but it contains those characters in their rotated format. As you can see here, this is what the actual ASCII uppercase is, but this is what our alphabet string is currently after performing the rotation. Okay, so that is what we are trying to do is so now what is going to happen is like let's say the encrypted password is this. Okay, so wait, just did not get copied, I guess. So let's suppose this is the decrypted key. So now what is going to happen is like the corresponding value for O in this string would be checked in this string, and then that value will be provided over here. So let's suppose like in this case O would get converted to, what is this position, 1 2 3 4 1 2 3 4 5 6 7 and 8. So it position from the end, 1 2 3 4 5 6 7 and 8. So it would get converted to R, and in the same way the entire mapping would be done. So let's just run this code once so that you get a better understanding of what is happening over here in reality. So rotation, we can pass our password over here, and let's for now rotate it by value say 3. Okay, let's run it. Okay, it has returned the value, but we are not captured it anywhere. So let's decrypted key equals, and let's print decrypted key. Okay, so after rotating by 3 positions, what we have got over here is this. Wait, I will explain this to you with proper example. We'll see over here. Okay, what did just happen over here? Print alphabets, join alphabet, rotate, value. What is wrong over here? Oh, okay. This should not be done over here. Cool. So maybe I can get it to some other value. Alpha equals join alphabets. Maybe this should fall. Print alpha. Okay. So yeah, let's see what has happened over here. So we know like this is our key that we want to decrypt. Okay, so let's see for O. over here. So for O, the corresponding value here is L, and that's why we got the value L over here. For M, the corresponding value is J, and that's why we have a J over here. And in this way, the entire string gets translated, you can say. But we can't check for each and every value, like passing one after the other value over here. So what we can do is we can write a loop for I in range of length of what we can say is string dot ASCII uppercase, so that would be 26. We know that very well. And what we can do is just shift it over here, and maybe we can pass the parameter I directly over here. Okay, and then we can just print this. Let's see what we get. Okay, we don't need all this. So this is what we get. Now let's see if there is anything that turns out to be meaningful. Okay, so here is the key. So this sounds meaningful. Caesar is easy. Let's try this to get access for level 3. Okay, so this thing has stuck. And let me tell you one solution for this. You can do is enter, then the tilde, and then full stop, and you are out. So basically that is enter plus this thing tilde and full stop. So this gets you out of any stuck SSH session very easily. So yeah, what we are gonna do is log into Krypton 3 with the password. Caesar is easy. See wrong with this. Alright, there's some issue, I guess. Let me just type in the password. CAESAR. Caesar is easy. Okay, and we got the access to Krypton level 3. So that is it. This was Krypton 3 for you, Krypton 2 for you, and in the next video we'll be working on Krypton 3. Thank you. And yeah, I'll also be providing all these links for whatever functions that we have used like translate, make trans, collections in the description, so you can use them and go to them for further reference. Thank you.